Hey guys, it's Preston, and I'm going to demonstrate the InOrder Traversal of a binary search tree. So here, just for simplicity and speed, I have already created a constructor binary search tree with some values passed in. So this dot value left and right are set to null. In the very beginning, we have an insert function or method that takes a value and inserts it in the tree. And down at the very bottom, we have the node class, binary node class, that adds that. This is the node that we are going to be adding to the tree. And here we have a new tree that we are setting up for our test to display that. So we're adding, so the tree itself is being initiated with 50 as the parent node, and then 15 is being inserted, basically going to the left, insert 66 is being inserted, going to the right of 50. And so here we go. We're going to traverse this function. So this is definitely going to be a recursive case. In its simplest form, if our tree just has one value of 50, then we want to just basically call this callback function on that value. So we are going to go callback function with the this dot value, because this is the constructor function itself, and then dot value is going to be the value that was passed in, so the parent node's value. So callback function with this dot value passed in. So that's just one case. So obviously if we run that, that's going to return 50. Because in this case, we're calling a callback function, which in our example, it's just pushing the value to that array. So now we need to take the case where we are adding something from the left, and then the parent, and then the right. So left, parent, right, or left, self, right. So in order to do that, we want to basically call callback func on this dot left, right? But what if we don't know if there is a left? So in that case, you might think, oh, well, let's just go if this dot left is not undefined, basically, then run callback func with this dot left passed in. But if you notice, that's exactly what we're doing here to this dot value. So we could instead just use recursion, which is a good idea, because then we can actually traverse not just a three node tree with one left, one parent, one right, but also an infinite number of nodes. So we call the this dot left dot traverse with that callback func. Passed in. So what did we just do here? So we are basically going, if we do have a left, if it's not null as we first define it, then we're going to take this dot left, we're going to call this method traverse on that. So now this dot left is actually the this in this traverse method. Thus we're going to be, so the this dot left is the this, so then we're going to pass that in. This dot left, if we just have one left node, then this dot left on the left, so this dot left does not exist yet, it's null. Therefore, this first case is not going to pass. We're going to go jump right down to line 34 here and pass in this dot value. So thus, this dot left dot value into the callback function. So if we run this, we would expect, just like we expected, 15, 50. So we are going left first, then we're going to pass in our parent node or the root node. Finally, we need to take care of the right part of the tree. So obviously, this is just going to be pretty much the same thing. If this dot right, then we need to go this dot right dot traverse callback func, and that should take care of it. 15, 50, 66. Great. So again, we could have just done this dot left, or we could have just passed in this dot left to callback func, but we want to be able to use that on multiple values, such as what if we go tree.insert 60. In this case, we're adding that to the left of this node, 66. So let's run that. And we get, as expected, 15, 50, 60, and 66. So let's take a look at what this looks like in the debugger so we can kind of step through this. Let me just add in 60 here. All right, let's run this. Okay, so we have the debugger calling, stopping us right inside that traverse method. So let's step through this. First, we're going to go, our value is 50, and so this dot left, we are going to, yes, this dot left does exist. This dot left is actually 15, so thus we are going right back into our traverse method. You notice we have 2 items on the call stack, 2 traverses on the call stack. This dot left of the left does not exist, so I'm going to go right down to line 33 there, and we're going to pass this dot left dot value into that. Thus, our vals array is going to have 15 in it now. Great. So now we are going to go to, so we're back at the root node, and then so we passed in that root node there, so 50 into callback func, so thus that has been added to vals. And we're going to go back down to if this dot right. So yes, we do have a right node, because as you recall, we passed in 60. So we passed in 66 actually first, and so this is going to go to 66. So this dot right, it's going to go to 66, value is 66, great. We're going to go right back into that traverse method. So again, 2 items on the call stack here. This dot left doesn't exist. Oh, it does exist because we passed in 60 after 66, so that's at the left of 66. So we are going right back into traverse method again. So now we have 3 items on the call stack because we are 3 items deep in our tree. So we're working on 60 is the this dot value now, so this dot right dot left dot value is being passed into callback func, and then calling that callback func, adding that to the tree. Let's step through it one more time. There we go, 60, and then there is no right node of the 60, so we're gonna go back up to our 66 node, and we're going to pass that into callback func. So that's the last step here, and that will be added to the array. So there you have it. That is the InOrder traversal of a binary search tree. Hope you liked it. Thanks.